Welcome to Debar Lab. Today we'll learn how this AC to DC conversion section and the power on off section works for the Creative A300 series audio system. The similar kind of circuit can be seen in audio amplifier or sound system, but here we are taking SBS A300 as an example, since it was with me for a very long time. I studied the board and we can get the basic idea about the overall circuit in my previous video. Will highly recommend you to watch that before watching this one, and then you can come here and can easily understand each of the sections. So in this current video we'll be talking about this AC to DC conversion section and the on off section. In the circuit board, if you see, so this is the audio driver board. So that main audio IC I have kept outside so that you can see the board very clearly. So in this driver board, so the AC to DC section is here, and that on off, that activity is governed by here a Q4 transistor. So we'll show you how the transistor works and how the circuit board switches on when you when you rotate this knob or you rotate this slider roller. Okay, when you switch it on, so how that on off action actually occurs and how that AC to DC actually happens, we'll show you in this video. Now in that process we'll learn about these things, how the diode works. So this is a typical diode notation. So anode side and cathode side. So if you connect positive side this side, the positive voltage and negative voltage, then current flows to this arrow direction. Okay. And we'll learn about the capacitor, we'll learn about the transformer and about transistor. So here in this on-off section, the transistor in use is a PNP type transistor and A1015 transistor number. I will show you the datasheet of this transistor also, and we'll simulate this AC to DC section along with the on-off section in a circuit simulator, in an online circuit simulator called Every Circuit. So let's see what happens step by step. So if we draw a basic schematic of this AC to DC and on-off section, it looks like this. So here is the 40 Hz supply AC, and this switch represents that on-off switch in your power socket, and that AC supply voltage gets converted to a lower voltage AC using a transformer. This is called step down transformer because the voltage is getting lowered. So, and that happens into this adapter, this power adapter. In this adapter, if you see inside, there's nothing but a transformer. This kind of transformer is there inside this adapter. So here the 220 volt gets reduced to a 12 volt AC. Okay, this is AC to AC transformer, and this power jack gets connected here. Yeah, this socket. This is the AC socket. Okay, so here the 12 volt AC comes, and that 12 volt AC, so the 12 volt AC goes to the fuse. So this is the fuse that I was talking about, and from fuse it goes to a diode bridge. You see 4 diode connected in a certain configuration. This is called diode bridge orientation. So you can see here these are the 4 diodes. You see 1, 2, 3, 4. 4 diodes connected in a certain fashion, which will convert your AC supply voltage to unidirectional fluctuating voltage. So let me draw. So the supply voltage was like this, AC, in this section. Okay, so it gets converted to something like this. So unidirectional fluctuating. Okay, so This is till this point. Yeah, this point here. And now after the capacitor, it becomes, maybe I'll change some another color. So it goes to like this DC. So initially it was AC, then DC. Actual DC happens here. Okay, we'll see what things are happening in circuit simulator. Now that DC supply that goes to a PNP transistor. So this is the PNP transistor used for on-off purpose, and this side is the emitter side, and this is the collector side, and this is called the base of the transistor. So just to remember, the side of where this arrow exists, this arrow, that side is always the emitter side of a transistor. So you see here, this is the transistor, how it looks like. It's having three legs. So one is the emitter, collect, another one is the base, another one is the collector. Now out of these three, which one is the emitter, collector, base? To see that, it's always better to check the datasheet of the transistor. Now again come back to the capacitor. So we'll see how that fluctuating current becomes DC here in simulation, and here this power capacitor, this one. So you can see that power capacitor, you can see here this large size capacitor, this one. This is the capacitor, this power capacitor, 1 millifarad capacitor. So it actually dampens this fluctuation, unidirectional fluctuation, and converts the voltage to a truly DC voltage. Now one interesting point here is, you'll find one very small capacitance capacitor, and that too a non-polar capacitor. You see here you have a polar capacitor here, large size polar capacitor, and you have a C31, a non-polar capacitor here, just parallel to this polar capacitor. So what's the purpose for that? So whenever you use a large capacitance capacitor, it's having a very high amount of equivalent series resistance. Now to handle that large equivalent series resistance, it's always a good idea to have a small amount of non-polar capacitor in parallel. So that enhances the characteristics of the capacitor, and that also increases the life of the capacitor. Now let's see how things works in the circuit simulator. So here is a window of every circuit, and the AC to DC conversion section and the on off section is working right now. This is simulation is on. Though I have the entire circuit model for the sound system, I'll not going to talk about those sections, so that will be very much confusing for you. So I have taken that this AC to DC section outside of this main circuit board. As of now, this 10 ohm resistor, this is representing the total circuit load of the audio system. Let's see what are the things happening step by step. So as of now, let's keep this switch open, okay, and stop the simulation. So here, this is the AC supply, and this switch is the power socket switch. So if you connect this switch, the AC power supply will come to the transformer. This transformer is nothing but that wall mounted power adapter. So from there, the step down voltage goes to the diode bridge. Now what happens in this transformer, let's see. So in transformer, you have a magnetic core, you have a supply side, and you have a secondary or primary side, and this is secondary side or output side. So here the AC supply comes input, and there goes the AC output side. This is the output side or secondary side, and this is the input side. Now, how this works, the current transfer happens here by magnetic coupling. So the fluctuating current, alternating current AC gives rise to a fluctuating magnetic field here. So this magnetic coupling creates couples these two coils, though they are not directly connected through any wire. This fluctuating alternating current in the supply side creates another fluctuating alternating current in the output side, this side. Now the voltage, the how much voltage is getting generated here and how much voltage is supplied here, they are related based on the number of coil turn in the supply side and discharge side. So if one is the inlet input side and two is the output side, so they are related. Like if you want to know what's the output voltage is going to be, then this V2 by V1 is equal to N2 by N1, or V2 equal to V1 into N2 by N1. So just by changing this coil turn count, you can get a reduced voltage. In that case, the transformer is a step down transformer, means when this N2 is less than N1, in that case, of course, V2 is less than V1, so that point is a step down, and the opposite is true when that is a step up transformer. Means I'll just write again, N2 is greater than N1, then your V2 output voltage will be greater than V1. So this is going to be a step up, and this was step down. Okay. So this was about transformer, and the same thing is happening here in this coil. So you see 210, this is the coil turn ratio. The voltage is getting down, stepping down accordingly. So it's around 20 factor reduction. So 200 is getting down to 10. So I've taken some approximation here just to reduce this 220 voltage to somewhere around 12 13 volt kind of number. Now that voltage leads to a current flow here in the circuit, and that current passes through the fuse. So that fuse having two purpose here. So first of all, it prevents large amount of current flow in the circuit, because so if some short circuit happens there, so that current has to be limited by a resistor, because so this is the resistor. And second, if some excessive current flows into the circuit, so finally this fuse is going to blow and protect the downstream circuit. So it was about the fuse, and it goes to the bridge arrangement here in the diode. Now let's talk about the diode. So the notation of diode is like this. So the basic idea of diode is, if you connect the positive side this side and the negative side this side, so this is going to allow current flow. Now if you connect the opposite way, means this side is a positive and this side is negative, and this current flow is not going to happen. And that same thing is represented by diode characteristics also. So if you give a positive volt or the positive bias, means this direction, so after a certain voltage, so this voltage is typically between 0.3 to 0.7 kind of number. After a certain voltage, the current flow, the amp, increases rapidly. This is the V. Okay. And so So the current flow increases rapidly, so it behaves like a no resistance path. Though with a fixed zero point 0.3 to zero point 0.7 based on the type of diode, it's a silicon type or germanium type. Normally, germanium types gives the lower delta V voltage drop. The zero point 0.3 comes for the germanium type, and for silicon type diode, it comes to be around zero point 0.7. So this is a followed by a scenario, and if the opposite things, the reverse voltage comes, typically it doesn't give a flow. So it works like a NRV, non-returning valve. It allows the current to flow in one direction and prevents the current flow in the opposite direction. And one special thing also happens there. It's called a Jenner diode. After a certain voltage, some kind of avalanche phenomena happens in that opposite direction. So that negative voltage means this side is positive and this side is negative. In that case, a large amount of current flow happens, and that is actually used for voltage regulation purpose, circuit protection purpose, and that kind of diode is called Zener diode. And a special notation is used. Let me use another color. So that notation is somewhat like this. So this extra lines are represented for Zener diode, and this Zener diode is always used in reverse bias. Means this side is kept as positive and this side is negative, and if certain voltage based on the characteristics or type of the Zener diode, if the delta V, the voltage difference, goes beyond the certain value, then this avalanche flow of current happens. This very large amount of current flow happens in this reverse bias direction. That is used for circuit protection. But here in this case, we are not using this Zener diode here in the AC to DC conversion. We are using this diode, where after a certain voltage drop, it allows the current to flow in one direction and prevents the current flow in another direction. So our operating region is not in this region, so till this region, so it's only unidirectional current flow. That's the purpose here. Yeah, coming back to here in the circuit simulator, this four diode arranged in this configuration results in a unidirectional current flow. So let's see how it happens. Let's switch on the circuit. So initially this current flow is happening because of the capacitor is already charged and it is getting discharged. So see, I can maybe, okay. So I can start the circuit right now. So you see. So let me open this voltage watch. You see this fluctuating voltage. Okay, and and what is happening here? You see the fluctuating sinusoidal voltage of this power socket. But if you see what what voltage is getting here, we are getting here after the diode, it's a flat voltage. You see the value green. The 4.87 is the max value and minimum value is 3.98, is somewhat 4 only. So this fluctuation has gone out and it's giving a flat value, though it's not the dual pole that I was talking about because of the resistance and the coil ratio that we have taken. Anyway, you can change these ratios and get a higher value. Here, let's say if I just increase this value, let's say in 20, so you can get a higher value here. So for that, first it has to run for a few minutes. So maybe you can see already it's increasing. Okay, so you can increase that voltage by playing with these ratios and see how things are working here. See, in one cycle, one diode is allowing current flow and another diode is preventing. Okay, so as a result, the voltage is getting unidirectional. and that unidirectional fluctuating current is getting flattened by this capacitor. So if I remove this capacitor, you can see that this voltage is going to be a like single hump kind of unidirectional hump kind of thing. Okay, so this was about this AC to DC section, and if you see here you have the low capacitance non-polar capacitor kept parallel to the polar capacitor. It helps to reduce the equivalent series resistance of this large size capacitor. So now let's see what happens in the on-off section. To understand that on-off section, I'm going to say this section. I'm going to say this section. Okay. So I have to understand the core item. Here the core item is the PNP transistor. Yeah, this one. Here is the A1015 transistor, and this is a depiction I have taken from the datasheet. So E emitter, B and C. Here you have this side, this is the emitter, this is the emitter, this is the base, and this is the collector. Now one uh, very good technique to remember the current flow is this following this arrow. So what I use is, so if I maintain a certain base for this transistor so that the current flow happens in this direction. So if the current flow happens from emitter to base, in that condition, if a suitable voltage is given, then the major amount of current can go from emitter to collector. So I'll repeat it again. So you have a three terminal emitter, base and collector. The main current flow terminals are the emitter and collector. So this is the main pipeline. You can think of like a water flow. This is the main pipeline, and you want to for water flow. Here this is a current flow for where, and you would like to control this amount of water flow or current flow by adjusting something in B. Now here in PNP transistor, that something is the voltage. So you'll play with the voltage in B in such a way a small amount of current flows from E to B, and that's what this arrow signifies. Okay, so that small amount of current flow will allow for a very large amount of current to flow from E to C. Okay, now using that principle of the PNP transistor, that circuit switch on off is occurring into this sound system. Let's see how it's happening. So we'll first brief the concept and show you in the circuit simulator. Here I have shown you that certain, let's say 10 or 12 volt of current of voltage is getting generated here. Now when this switch is open, this emitter and base are eventually in the same voltage because there is no current flow into this region. So when this switch is open, there is no current flow in this through these resistors and LED. So this voltage and this voltage is actually same. Means what I can write, VE is equal to VB, emitter voltage and base voltage is same. Now in that case there is no current flow between E and B. So if there is no current flow, there is no current flow in between E and B, there is no current flow in E and C. Now what happens when you close this switch? When you close this switch, a certain amount of current starts flowing into this circuit. Okay, and it glows this LED. Now When that current flows into the circuit, it glows this LED. So current flow means some voltage drop is there and some voltage drop is also there. So some voltage drop means it means your VB is now less than VE. So that results in a small amount of current flow in this direction. Okay, call it IB. Now IB is not equal to 0. It has some value. Now based on that IB value, a large amount of current from E will start flow. That is emitted to collector current. Can say IC. Now that IC is equal to beta into IB. Now when that IB is not 0 and beta is very significantly large value, then IC will be very large value compared to 0. So we'll get a large amount of current flow through this resistor and the transistor, and that thing happens when this switch is closed. And exactly the same thing happens in the circuit board. Let's see in simulation. So here you can see, for reference, I am showing the Toshiba datasheet for the A1015 transistor. You can see base emitter for a given base emitter voltage. So some base current, that IB I was talking about, based on different temperatures. Some certain IB can be obtained from this datasheet, and now based on that IB value, okay, based on that IB value, you can land here. Let's say what's the IV value. Now based on that IV value, for a given collector emitter voltage, you can get a collector current or IC. So since all other important parameters like the maximum voltage that can handle this transistor and the pin nomenclature, etc., like you see here, you have the left side is the emitter, then you have a collector and the base. This is emitter, collector and base. So this kind of identification can be done from datasheet, and the characteristic data can also be obtained from the datasheet itself for actual sizing and understanding of the circuit. Now let's see into the circuit simulator how things are working. So I believe uh, the circuit simulator is visible to you. And again, coming back to every circuit, so let's switch it on. So first, let's see, here I have switched off the transistor, PNP transistor, so this LED is not glowing, and whatever AC to DC conversion is happening, and that charge is getting stored into this capacitor. Now once the capacitor will be charged fully, then this charging will get stopped and nothing will happen, but the capacitor will be in a charged state. So when you close this switch, that is equivalent to rotating your that switch on knob or slider switch kind of thing. So when you connect this switch, you see here you see here the voltage is 29.8 volt and 30.1 volt and 30.1 volt. So this voltage is a identical voltage, because there is no current flow in this resistor. So if this voltage is, I'm going to say this voltage, I mean to say this voltage and this voltage, this here you have a VE and you have a VB. This VE and VB are identical, that means there is no current flow through the transistor. So that's why there is no current flow in this direction. Right now there is no current flow. Now if you if you just connect this switch, let's see what happens. If you connect this switch, okay, so now see what's the voltage here. You can see orange is 11.6 and the green voltage, orange is 11.6 and green is 1413, so it's is a delta V voltage gap between this emitter and base. So a net current flow is there in this direction, in this direction. So some IB is there, IB is not 0 now, so that results in a IC is a very greater than 0, a significant high value current flow in this direction. And you see that also this current flow from this 1K resistor, and the base current combined helps this LED to glow. That signifies the power is on. Yeah, thank you. So these are my very basic initial videos. So if you like these videos, please like and share. So we'll post this video time by time.